This video is for lesson 34-1, surface area of prisms and cylinders. Learning goals are to solve problems that involve lateral area or total surface area for a prism, and to do the same thing for the shape called a cylinder. The real-life scenario this time has to do with tents. One type of tent has this net. When you fold this up, it makes a triangular prism. So let me draw a picture of the triangular prism-shaped tent. The base is an equilateral triangle, and then I'm going to draw back into the distance to create the illusion of 3 dimensions, and then the back will also be an equilateral triangle. I'm going to use dashed lines to be the hidden edges. If the tent was transparent, you would see these edges. So here's my drawing of what this tent looks like as a 3-dimensional object. Now we have some distances given to us. The sides of the triangle are 6 feet. So 6 feet there, 6 feet there, and then this edge here is 6 feet. The triangle that is the back of the tent would also be 6 by 6 by 6. Now the length of the tent from front to back is 8 feet. So here are all the numbers provided to us in the net translated into the 3-dimensional picture. What we're going to do in this lesson is find 2 different areas for this 3-dimensional object. One is called the lateral surface area. It is the surface area of the shapes that connect the bases together. The lateral area does not include the area of the bases. So the lateral area of this tent are the 3 rectangular panels that form the sides of the tent. The lateral area is not the triangular ends. To find the lateral area of this tent, we can create a formula. Let's use LA to represent lateral area. For this object, it's 3 rectangle shapes, and all of the rectangles are congruent. So we could multiply 3 times length times width. This makes 3 times 8 times 6. The lateral area of the tent is 144 square feet. Another type of surface area we're going to explore in this lesson is total surface area. This includes the lateral area plus the area of the bases. We could create a formula for total surface area, perhaps TA for total area. In general, it is the lateral area plus the area of the bases. In this object, there are 2 bases. They're both congruent triangles. I'm going to write 2 times capital B, where I'm using the capital B to be area of the bases. The lateral area we had figured out was 144. And then 2 times the area of the triangular base. So let's focus our attention on the triangle that's closest to us in my drawing. We need to find the area of that triangle, and we find the area of a triangle using the formula area of a triangle equals 1/2 base times height. The base of the triangle is 6. The height of the triangle is not drawn in our picture, but we can find that. If we draw straight down from the top to the middle of the bottom, it makes a 90-degree angle. The distance from here to here is 3 units. We have a right triangle shape where we know one side is 3, the hypotenuse is 6, and the height is missing. Let's use the Pythagorean theorem to solve for height. I'm going to do that on the left side of the screen. 3 squared plus 8 squared equals 6 squared. This is 9 plus 8 squared equals 36. Subtract 9 from both sides to get 27 and do the square root of 27. The height is the square root of 27. Now we can find the area of the triangle. 1/2 times 6 is 3 times the square root of 27. That's the area of the triangular base. So now to the bottom right corner of the screen where we're working on total area. We did not know what to fill in for capital B, and now we do. 3 square root of 27. Let's figure this math out to get the total area of the tent. It is 175.1 square feet. Total area will always be larger than lateral area because total area includes the area of the bases. Flip to the next page. Now, a lot of these questions we've already answered as we worked on that tent problem together. But where we have question C, let's write a formula for lateral area. Then we can use this formula whenever we need to find the lateral area for a prism. So lateral area for a prism is equal to the distance around the base, we might call that perimeter, times the height of the prism. In this problem, I'm using letter P to be perimeter of the base. And the letter H is height of the prism. Please put that formula on a note page to use on tests. LA means lateral area, P is perimeter, H is height. For the tent that we just did, the perimeter of the triangular base was 18. All three sides were 6. And the height was the distance from the front triangle to the back triangle. That was 8. And 18 times 8 was our answer of 144. Now number 5. We've already found the total surface area for our tent problem, but where 5b is, let's write a formula for finding total surface area. We're going to use SA to mean total surface area. We're doing this for a prism. The way that we found it for our tent is we took our answer for lateral area and then added 2 times the area of the base. So SA is total surface area, LA is lateral area, something that we can figure out using a formula, and the capital B is representing area of the base. There's a 2 here because a prism has 2 bases. Go to number 7 and let's use our formulas for a different shaped tent. Mike's tent has this shape. This is a prism, but this is a pentagonal prism, not a triangular prism. I know it's pentagonal because the base, which is the front and back of this tent, is a 5-sided shape. Let's find the lateral area first, and then the total surface area. For lateral area, we're going to use our formula, perimeter times height. The perimeter refers to the perimeter of the base, the distance around the pentagon base. 5 plus 4 plus 8 plus 4 plus 5. That's 26. Height refers to the distance between the bases. In this drawing, the height is the 10, the distance from the front pentagon to the back pentagon. 26 times 10 is 260 square feet. The lateral area of this tent is 260 square feet. The lateral area are the rectangular panels of the tent that connect the front to the back. Now let's find the total surface area of the tent. In the formula we wrote down a bit ago, we used the letters SA to mean total surface area. Our formula is to take the lateral area and add 2 bases. So for capital L, it's 260. And then 2 times the area of a base. Each base is a pentagon. We need to find the area of the pentagon. Let's do that up here on the left side. We're going to find the area of this shape, the pentagon-shaped base, the front of the tent and the back of the tent. To help us out, do you notice the dashed line splits the pentagon into 2 trapezoid shapes? Let's find the area of those trapezoids, add them together, and that would be the area of the pentagon. We're going to do 2 times the area of the trapezoid. Let's find the area of the trapezoid. It is 1/2 times the height, which is 4, times the sum of the bases, 4 plus 7. This is 22. So the area of the pentagon is 2 times 22, which is 44. That's what we fill in for capital B over here on the right. Take your calculator, type this in, and you'll have the total surface area of the tent. This is 348 square feet. The total surface area includes the lateral area and the 2 pentagon-shaped bases. Move ahead to number 9 in the Check Your Understanding question. Let's find the lateral area and the total surface area of this prism here. For lateral area, you need to use your formula perimeter times height. For total surface area, you take your answer for lateral area and add 2 times the area of the triangular base. I'm going to pause the video for you to find these answers. And here's what you need. The perimeter of a triangle is 9 plus 12 plus 15. That's 36. The height of the prism is 5. 36 times 5 makes 180 square units. For total surface area, we fill the 180 for L and then fill in the area of the triangular base for capital B. On the right side of the video, let's find the area of the triangle. 1/2 base times height. The base of the triangle is 12. The height of the triangle is 9. This makes 54, and that's the answer that gets filled in for capital B. Taking a calculator, typing this last piece in, we get 288 square units. Move down the page till you get to the picture of the sleeping bag. The sleeping bag is a cylinder shape. And let's find the same 2 things we were just practicing, the lateral area and the total surface area. The lateral area of a cylinder is the surface area that does not include the 2 circle bases. It would be the rectangular part that wraps around to form the sides of the cylinder. Previously, when we were discussing cylinders, we said that the distance around a cylinder is the same thing as the circumference of the base of the cylinder. And to find circumference, the formula is 2 times pi times r. In that same section, we said that the width of the rectangle that wraps around to form the body of a cylinder is the same thing as the height of the cylinder, the height meaning the distance between the circle bases. Putting those 2 things together gives us the formula for lateral area. Surface area will be the lateral area plus the area of the 2 bases. But the bases are circles, and we know a formula to find the area of circles. So we're going to have 2 times pi r squared. Pi r squared is how you find the area of a circle. So with these 2 formulas, we can find the surface area of that sleeping bag. In the story problem, it tells us that the radius of the circle is 6 inches, and that the height of the sleeping bag is 15 inches. Those are all the things we need to know to use these formulas. So for lateral area, 2 times pi times 6 times 15. This makes 180 pi square inches. If you want, you can put 3.14 in for pi and get this as a number with no Greek letter in it. For surface area, we take that same answer, 180 pi, fill that in for lateral area, and then add 2 times pi times 6 squared. This makes 252 pi square inches. Again, you can replace pi with 3.14 if you want to have an answer that doesn't have a Greek letter in it. Jump ahead to the Check Your Understanding number 17. Here's a picture of a pipe. We're told the pipe is open on each end. So when we find the surface area of the pipe, we're not going to include circle-shaped bases because those are just open. Chester gets the answer as 32 pi square feet. Maria gets the answer 24 pi square feet. Which student is correct? So we want to find the lateral area of the pipe, not the total surface area, because there are no circle bases this time. The formula was 2 pi r h. Let's fill in our values. For r, fill in 2. For h, fill in 6. 2 times 2 is 4 times 6 is 24 pi square feet. This means that it was Maria who was correct. This problem points out that when you're doing a real-life problem involving surface area, you have to pay attention to whether the bases are included in your surface area. In this problem, they're not because a pipe is open on both ends. Let's summarize this lesson. We discussed how to find the lateral area and the total surface area for two of our three-dimensional objects, the prism and the cylinder. In a different lesson, we'll discuss how to do this for a pyramid or a cone. But in this lesson, to find the area of a prism or a cylinder, use the formulas that you wrote down in your notes. Because you're finding area, remember to give the answer in square units.